Okay, so when we're looking at trends in graphs, what we're talking about is graphs can be typically what we're considering linear, quadratic, or exponential. So when we're starting with this, we're going to look at a linear graph, so a straight line graph. Now, typically what we're talking about is something that's going to be, I don't know, like this. We'll go down. Okay, where we have our initial value. Okay, which is the starting point or the y-intercept. Okay, now the graph is always going to be graphed in something like y equals mx plus b, where we have b is our initial value and m is our slope, it's rise over run. Okay, the next graph we can look at is quadratic. So quadratics either look like this. So if we had our graph, so a quadratic can look something like this. Or we could be considering a quadratic that looks like this. Okay, they're very similar. They're rounded at the tops and bottom there, but I kind of V'd mine out. The bottom or the top, these are the vertex. Okay, so that's the vertex. Obviously, you have x-intercepts here where it crosses the x-axis and a y-intercept there. We could look here, x-intercept, y-intercept, x-intercept. They're going to tell us different things based on different parts of the graph. Now, an exponential relation is going to be something like this. Okay, so we've got our graph. So it could look something like this. Okay, again, we have a starting point. This is when our values are going down. Okay, so that would be decay. And then this is when our values are going up, and that would be growth. Okay, typically for a quadratic, we forgot to put it down, but we'd have y equals ax minus h squared plus k. That's kind of the normal formula. And for an exponential, we've got something like this, where the x is actually in the exponent. Okay, so the x is in the exponent for the exponential, and we have an exponent of 2 for the quadratic. All right, so let's keep moving along here. So determine the slope of each line. So we're looking at linear graphs here. So determine the slope and what does it represent? Okay, so to find the slope, we really just have to look at a part of the graph and do rise over run. Okay, so what I'm going to do is I'm going to choose the easiest one. I'm going to go 0, 0, and 160. Now you could choose 2, 120, and 3, 180. It would give you the same thing. What we're going to do to find this is our slope is always our rise over our run. So how much did we go up divided by how much did we go across? Here we went up 60, we went across 1. So our slope is 60 over 1, or 60. Now, if we look at what we're actually comparing here, we're comparing kilometers and hours. So it's kilometers per hour. So the slope actually represents speed in this case. Now, if I chose any of the other points, I would get the same thing. 120 over 2 is equal to 60. 180 over 3 also equals 60. You could choose any of these points, go up and actually calculate those out. All right, let's look at the next one. So the next one, what we have to do is we have to notice the graph isn't going up and down by the same thing. So we're going down, let's say, here to 500, or even let's go right down to 0. If we go down to 0, we go all the way across to 5. So our slope is going to be negative 1,000, because we've gone down 1,000, over 5. We've gone over 5. It's got to be negative because we're going down. Okay, so if our slope is negative, we're going to have negative 200. We're comparing dollars to years. So what that is we are going down $200 each year. And we're paying, or our computer is losing that price. So what you have to actually do is you have to actually look at the graph. So what it's saying is the computer is losing its cost or losing its price $200 every year. All right, so moving on to the quadratics. So determine the coordinates of the vertex of the parabola and what do they represent? Okay, so our vertex is always our middle point. So you can most of the time see it on the graph. Now sometimes you might have to take your first point and your last point and divide it by 2. So we have 0 and 300, excuse me. So we add them together, divide by 2. That's 300 divided by 2 would give me 150. So that's my x. My x point here is 150. My y is just how far has it gone up. Okay, so it's at 150 and 22,500. Okay, each point isn't going up 5,000. Every other square is going up 5,000. So you got to be careful with that. Now this is the maximum revenue, so the maximum money we can make, maximum revenue of, what is it, 22,500 when we sell 150 tickets. Okay, so to make the most money, you'd have to sell 150 tickets. Now the next one, here's our vertex. Our vertex is at 2 and 22. Okay, and it's telling you the maximum height a ball reaches is 22 meters at 2 seconds. All right, so after 2 seconds of travel, the ball is at 22 meters. All right, so moving on. Graphs we're not going to really focus on exponentials. We've talked about it a little bit. Graphs can kind of have 3 broad trends. When we're talking about a graph, it can be increasing, going up. So this is increasing. Okay, so our values are increasing over that time. It's going up to the right. It can be constant or not. If it's a constant rate of increase, it's going to be a straight line up. If it's not, it's obviously going to be wavy. It can be constant when it's flat, so there's no change, or it can be decreasing when it's going down, same as going up. All right, so if we look at this last graph here, second last graph, this graph is showing the number of births in Ontario between 1945 and 2005. And it's asking us to describe the trends. So what we're going to do is we're going to look, when is the graph going up? Well, it's kind of going up here all the way to right there. Then it's going down from right there to right here. Then it's flat to there, up, down, up again. Okay, so we can fill in our years here actually just by counting. I believe it's going by 5s. So this is 1960. Which is an important point. Then we've got 1970, is that 70? What do we got? 45, 50, 55, 60, 65, 70, 75 to 80, and then 80, 90, and then 100. So 100 is actually 2000, to the year 2000. Take that 100 out. And then 05. Okay, so looking at this, from 45, so 1945 to 1960, it's increasing. The births are going up. Okay, then from 60 all the way to 75, it's decreasing. The birth rates went down. Okay, and you would write the birth rates went down or they're increasing, they went up. I'm just kind of going through and showing you. From 75 to 80, it was constant. From 80 to 90, it increased again. From 90 to 2000, it decreased. And from 2000 to 2005, now it could keep going up, but in this case, it's just showing until 2005. So we don't know. So in this case, it's increasing until 2005. Now, the last example, okay? So we've got, use this graph to predict what's going on. So we're predicting some more information. So use the graph to predict the number of Canadians in each age group in 2010. So all we're gonna do is we're gonna go to where 2010 is. Now 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 would be 2010. It's right at the end here. So all we have to do is kind of dot over to where that would be. We would draw a straight line with a ruler. It looks like under 18 and over, or 15 and under and 60 and over are roughly going to be the exact same actually. Now, so those two are the same. This one down here, the 80 and over, is going to be a little smaller. Okay, so I'm just going to write them up beside it. So what we'll do is I'll erase this stuff. So we've got that. So what we're going to have for A, this is going to be roughly, I don't know, like 5.8 million. It's not quite 6 million. But we can see it's roughly 5.8. It's almost, if you wrote 5.7 or 5.75, you would still get the marks. Here, we've got about 1 million. That one's easy to see. Now in B, what decisions might the government make that would respond to this graph, or it might change this graph? So things that you want to look at here, it's no actual math, but you want to think about things that are going to change the graph. So things like retirement age and healthcare and immigration and things like that are things that you would say for that answer. Okay, there are some questions here that you can look at.